Hello students. So in today's class we are going to discuss about a new lesson, electric current and its effects. So in class 6 you would have studied about the basics of electricity, like how electricity is being generated, how the current flows, and how the electricity is being produced from the natural resources like water, coal, fuel, and all these stuffs, how it is being converted into the electricity, how the power has been generated. So all these things you would have discussed, right? And now we are going to discuss because of electric current, what are the effects that takes place. That is what we are going to discuss. Especially when you see here, two possible effects will happen. One is the heating effect of electric current, and the other one is the magnetic effect of electric current. So when you look at the heating effect of electric current, what happens actually when the when the electricity passes? So when an electric current flows, you would have discussed about the good conductors and bad conductors of heat, right? So similarly, good conductors means the materials that allow the current to pass through it. So similarly, when you take the wires, in case if you're charging a phone, so the phone gets charged because of the wire. And when you insert the adapter to the plug socket, what will happen? The current flows through the wire to the what to the mobile phone. So that is how the mobile phone gets charged, right? So similarly, when the electric current flows through the conducting wire, what will happen? The temperature of the wire tends to increase. So when the temperature of the wire increases, that represents the heating effect of the electric current. You got it? And now when you look at the magnetic effect of electric current, so magnetic effect means usually which attracts things. Right, but here in the electric current, what will happen to understand how the magnetic effect takes place because of current? You can do a simple experiment like when you bring a compass, the direction showing compass. Yes, when you bring the compass near to the current carrying conductor, the needle of the compass tends to get deflected. Yes, so when it gets deflected, you can understand that there is a flow of electricity. It is because of the flow of electricity, the needle of the compass tends to get deflected, and that shows how the electric current even it produces a magnetic effect. So these are the main two effects which happens because of the electric current. And some of the examples which you can consider for the heating effect of electric current or the incandescent bulbs. So incandescent bulbs, when you switch on the light, what will happen? The bulb starts to glow, right? So when the bulb glows, you after a while, if you switch it off, and when you touch the bulb, you could feel the heat in the bulb. So it is because of the heating effect of the electric current. Got it? And now we are going to see what is the effect of electric current on the human body. And if you consider the human body, it is a very good conductor of electricity. So we have to be very careful enough when you are working with electrical appliances or when we are handling the electrical related things. So we have to ensure carefulness when we are doing all these steps. So when an electric current passes on a human body, what will happen? First thing, it creates severe burns in the body. And the other thing is, it depends upon the electric current that pass on the human body. It may tend to cause a cardiac arrest, or it may burn the tissues and organs inside the body, or it may cause the muscle spasms. Then some kind of serious effects are also tends to take because of the nervous system. It affects the nervous system even, and sometimes the person may go unconsciousness, and if it is going to be a high voltage current, it may burn the person into ashes. So all these things happens because of the electricity. So we have to be very careful enough when we are dealing with electrical related things. And what they have given here, see here, they have given a circuit. They have given some electrical components. They have connected some electrical components to check whether the current flows or not. Here they have used an electric cell over here. So an electric cell contains the positive and negative terminal. See here, one end of the positive terminal has been connected to an iron nail, and from here a wire has been stretched from one end to the other end of the nail, and a key has been fixed inside this wire, inside the string, and one end of the key wire has been connected to the bulb, and from the bulb again one end has been connected to the safety pin. All these things tends to transfer or tends to carry the conductor or tends to flow the current. So it easily carries the current from one end to the other end. So that's why they have used all these things. And the safety pin has been fixed to the drawing pin. So the other end has been connected to the negative terminal. So if you want the bulb to glow, the wire should be connected to the positive terminal as well as the negative terminal. So that is what they have done here. And what you're going to do here is when you try to move the key from this end to that end, you have to ensure that it touches the string. If it is not going to touch the string within this hole, what will happen? The bulb will not glow because a connection is getting affected, right? So if it is not going to touch the string, the bulb will not glow. If it touches the string throughout from one end to the other end, what will happen? The bulb glows. So that is what the setup has been given to check how steady your hand is. And let us see some of the symbols related to the electrical components. So every time when we discuss about the electrical components, it is not always possible to draw the perfect diagram by using the electrical components to describe the circuit. So it will be quite confusing even at times. So every time when we try to display an electrical appliances to show the circuit diagram, we will find it a little boring and it is time consuming even. So for each and every electrical appliances that we use has been given a particular symbol to draw a circuit diagram. So circuit diagram helps us to understand the flow of current or how the connection has been given by using all the electrical appliances. So that's why the circuit diagram is basically used in physics to understand the flowing of current. See here, some common electric components can be represented by the symbols. So I'll show you. For if you consider the electric cell, in electric cell you have positive as well as a negative terminal, right? So how they represent the positive and negative terminal in a diagram, let us see here. See, if it is going to be an electric cell, it will be represented with one longer line and the other one is the shorter line. This longer line represents the positive terminal and the shorter one represents the negative terminal. So this is how an electric cell will be represented with a symbol. And if it is going to be an electric bulb, that will be represented like this. And if the switch is going to be in the on position, that will be represented with this particular symbol. And if it is going to be in the off position, see here the wires are not connected over here. If it is going to be in the off position, so here this will be represented like it's been lifted up. This line has been lifted up, right? And if it is going to be a battery, two electric cells connected together will be called as a battery. Got it? See here, this is the positive terminal and this is the negative terminal, and the negative and negative terminal will not be connected together. Always the opposite signs will be connected when you are trying to fix an electrical appliance, when you're trying to operate an electrical appliance using a battery. So this negative terminal and the positive terminal has been connected together. That is how we are supposed to connect it. And always a wire will be represented with this kind of a line. So that is what they have given here, the symbols of electrical components. See here, the longer line represents the positive terminal in an electric cell and the shorter line represents the negative terminal. And similarly, the switch on and off position are represented by the respective symbols over here. See, once again I'll tell you, this represents an electric cell. This symbol represents electric bulb. Switch on position, switch off position. Two cells connected together is called as a battery, and a wire will be represented with a line. And do you know what a battery is, first of all? So a battery means when two or more cells connected together, when two or more cells comes in combination together, that represents a battery. So you can take many simple examples like torches or transistors or any toys or TV remote controls. If you take all these devices operates with the help of a battery. Even the wall clocks. Yes, all these devices when operates with the help of the battery, how the battery will be connected over there, a positive terminal and a negative terminal will be fixed together. So the positive terminal of one cell is connected to the negative terminal of the next cell. You should not fix a battery with positive and positive together because it will not work. So that is how we have to fix the batteries inside the devices. So apart from these, see here, in some of the devices, the electrical cells are not always placed one after the other. So if you look at over here, see, a battery of two cells. So two cells together, you will call it as a battery. Sometimes four cells together also, you will call it as a battery. But however you connect, it should be connected with the opposite ends. So negative and positive, negative and negative. Sometimes it takes place like this. See here, negative and positive and negative and positive. So this is how it happens. And the remaining stuffs we will discuss in the next class, children. I hope you understood this class. Thank you.